So,
We have curtains.
no. Oh, there we go. So now be careful what you say. Don't mention that crime.
I will not mention that thing. I will not mention that thing.
Folks, I'd like to introduce Matt Richardson from... Oh, gosh, I forgot that again. Oh, that octopusy thing, yeah.
Octopus Deploy.
So how come your email's still the other one?
Because that's the company I started when I was here.
Oh, okay.
Rico.
Yeah, Rico, yeah.
Because I'm too lazy to change that.
Okay. Right, so, in your hand?
Just wait till the end. Just wait till the end. If you're still awake, I'll count that as a win. So, right. So, thank you for turning up. It is 6:30 on a Monday night, so I'm impressed you're all here. I'm impressed I'm here. So, I'm going to talk about continuous integration, continuous delivery, and DevOps. And I know you've actually already covered this in your lectures so far, but I really want to emphasize it because there is such it can really have such a massive difference in your work, your organisation, actually even just your quality of life. And that's a big claim, I know. So hopefully I will convince you of this, and if not, you can ask for a refund later. So, who am I? I'm Matt Richardson, as James said. So we've been doing this stuff professionally since '98. I've been doing it for a lot longer than that, though. I remember getting excited when VB for DOS was released in '92, which is a very long time ago. So I did CSSE here. I think I graduated in 2000, and I spent much more time in the local coffee shop than I really should have, but somehow I still passed. So, and then I started a company during my IBL year with Batman just there, and that's still going, which is,
Still going.
I think we're quite surprised about that, aren't we?
Yes.
So that's working quite well. And so now I work at Octopus Deploy, and Octopus is a friendly deployment automation tool based out of Brisbane, which means I get to work from home, which means I don't have to wear pants. So, I do wear pants, sorry. Sorry for that image. So, if you keep your questions to the end, it'll probably make it all work better. Now I was going to start a timer for this too, wasn't I? So I know what I'm doing. So, why do I care about this stuff? And why do I think you should care? So, far too often developers just want to write code. All they want to do is sit down, code, deliver their stuff, and that's it. And so if that's what you want to do, I completely understand. There's so much more to it. There's so much more to just writing code. And seriously, take a look at it, think it through, because writing code is that much of it. Delivering value is so much more. So we've got an industry problem where too many people just want to write code, and once written, it's often someone else's problem. So it's really one of the areas that needs a lot of love. So there's lots of great patterns in dev and ops that make life easier in those particular spaces, but it's the gap in the middle. It's the talking together, the merging of those that really makes the big difference. So it's the area that really has a lot of potential to make a big difference. So it's easy to imagine. It's like if you finish your code, you're ready to go, and then there's a 6-week what feels like arbitrary delay between your stuff being finished and getting to production. Just think of the wasted opportunity costs you've got there. And I really care about it because it's like I personally love enabling other developers to ship faster, better, with higher quality. So really, why do I think you should care? And if those reasons I've given haven't convinced you yet, there's really a wide variety of companies out there. Some what they call high functioning, some that aren't so great, shall we say. You really want to aim to work for one of those ones that gives you a sense of pride, achievement, quality of life. And you want something that you're excited to get out of bed in the morning, go and achieve something, make a real difference. So There are high functioning companies out there. There's some not so good. If you can get in the high functioning ones from the get go, awesome. Otherwise, hopefully what we're going to talk about today is going to give you a whole bunch of tools that you can affect positive change in your organisation. So, how do you publish your code? Start from basics. You've got to dev complete, and it's kind of a bit of this question to make you think rather than a real example, because you need to be thinking about this stuff from the get-go. From the first time you start writing your code, from the first time you start writing something you know is going to hit your customers, you need to start thinking about this from day one. So how do you do it? How do you get your code from your laptop out to your users? Do you build it locally and copy it onto production servers? Not great. If you're using Visual Studio, for example, do you right-click Publish? No. This is bad. It's great for demos, it's great for proof of concepts, it's great for home projects, but it's bad for your longevity of your code and longevity of your application and your sanity, really. So why not? Why shouldn't we do that? So imagine it's a small project you're working on, it's just two people. You've got Bob and Fiona. So you could have a different OS. It's like Fiona's working on Mac, and well, Visual Studio's not going to work very well there, so that's a moot point. The different OSs, so you're going to have different DLLs involved, different version dependencies, even just different versions of software, so different versions of Visual Studio, or Rob's using Visual Studio to publish, and someone else using Vim. And maybe even Bob's been downloading torrents, and he's got some malware on his computer he doesn't even know. So do you really want your malware from your computer into your production software? That's probably not going to go so well when the Australian Stock Exchange finds out about it. So all of this comes down to it's not repeatable. So what you want to do, you want to get this off your computer and building somewhere else that is repeatable. So if you're not building locally, you need to build on a build server. So there's oodles of them out there. There's TeamCity, Jenkins, GoCD, Travis, Circle CI. It's like the list just keeps going. They've all got their pros and cons. This is a picture of TeamCity. That's my current favourite. Going off it a little bit, but there's many more. So find the one that works for you. Play with it. Most of them have free versions of some description. Have a go. Find what works. So the entire point of a build server is to script those complicated steps. So to enable the build automation. So it gives you the consistent, repeatable builds. So every time it builds, it goes through the same process. Because you don't want it to be done on Bob's computer, where Bob forgets to do that one step where you need to edit that file. And then your production deployment doesn't work. So they're extensible. So you add plugins in. So you get yourself some code analysis, you get some code metrics, issue trackers, test runners, and TeamCity has like over 200 of them. So that it just your build, however special you think your build is, these build servers can really cover it off and make it easier to use. So the entire goal of them really is to increase visibility and make it obvious what is happening. And really, just imagine it's like that when we've got, that one, we've got that up on a wall, you can kind of see things are working pretty well, all our tests are passing pretty well. So you just got that information radiating the information to the rest of the teams, the rest of the company, to the business, what's going on. Just so you can have notifiers, like Slack notifiers, get told when your build passes or failed. So it really just stops you ever getting this badge. So if you got that badge, yeah, not great. So that sort of takes us rapidly onto continuous integration. So continuous integration and build servers are often looked at together, but they're actually quite separate. So build servers is about building your stuff. The continuous integration is about improving quality and reducing risk. So this book's sort of the seminal book on this topic. Worth a read. A bit dry, but worth a read. So it's defined, CI, it's defined as a development practice that requires developers to integrate code into shared repositories several times a day. Every check-in is then verified by an automated build, allowing teams to detect problems early. So out of this, the important bit is early. So you want to know these problems early, because the faster you can detect these problems, the quicker they are going to be to fix, the easier they're going to be to fix, the cheaper they are going to be to fix. So it's kind of a manifestation of the, if it hurts, do it more often. And this sounds like a bit crazy. If it hurts, do it more often. But if you think about it, it's, if you've got something that you do every 3 months and a 1 week deployment that you do every 3 months, well, if we're going to try and bring that back so that you're doing it every day, you can't do a 1 week deployment every day. So you need to automate, you need to make it easier, you need to encode those things, all those steps into your process so that you are making it super easy to do these things, and the pain goes away. So, CI principles. That's a really boring topic, isn't it? It sounds really boring to me. Hopefully it's not going to be too boring. So, always use source control. So the code should never be on Bob's machine. It needs to be on Bob's machine so Bob can work on it, but it should never only be on Bob's machine. It needs to be in a source code repository, centralized one. GitHub is the current winner of that. So you've got your known source of truth. This is what our code looks like. And everyone pulls and pushes into that. We'll put everything in there. So from your test scripts, your configuration, your database schema, third-party libraries, everything you can think of. So you know that there is one source of truth of what's going on. Oh, let's finish this one first. So what you want to do is you want to set it up so that on the first day someone joins your company, joins your team, they should be able to clone and pull your code down and get running as quickly as possible. You don't want to be in a situation where it takes 2 weeks to get to be a functioning, productive team member. And I have worked at a place where it took 2 weeks to set up my laptop to be able to develop on this application. It was painful. You don't want that. So, automate the build. That's the next one. We covered it mostly already, but the build needs to do everything. You don't want to have any manual steps. So you don't want to have to go, okay, the build happens, and then we go and configure the database manually. No, the build needs to do that, sort out the database as well. Make the build self-testing. Just because your code compiles really doesn't mean it'll run. And if it runs, doesn't mean it actually works. Doesn't necessarily mean it does what you claim it does, what you've been asked to make it do. So you really want to make sure you've got unit tests, integration tests, browser testing. You want to get fast feedback, you want to know really quickly that something is wrong and that something you've done isn't quite right. So you really need to look at these as an executable definition of requirements. So this is what I got asked to do. Yes, it does what I got asked to do, or even what I want it to do. So once you've got all these tests in place, you've got a great safety net for future changes, for bug fixes, for refactoring. Because you know that if you fix that bug over there, have I broken anything, or is everything else working as expected? Whew. So next one is everyone commits to mainline every day. That's commonly called master. But the main line is the main single source of truth of what we're shipping, the code we're shipping. So it's all about communication, really. So it's communicating to your team what you're changing, and it's your team communicating to you what they're changing. So if you've got a long-lived feature branch, imagine you're working on something for 3 months off by yourself. The longer you have that branch around, the harder it will be to integrate back in together. And just imagine, you're not really going to know what changes have happened over that 3 months between your branch and all the other branches that are happening. So if a bug is introduced, there's many, many more spots it could hide. So the goal here is to have small changes, so a small batch size. And so if you're making a commit to mainline every day, you're going to have to do something that's less than a day's work, aren't you? So the benefit of that is it's so much easier to remember the whole lot in your head at once. And doubly so, it's easier for someone to review and give you a useful review. I was reading the other day, there's a saying, if you give someone a 10-line pull request, they'll find 10 bugs. If you give them a 500-line pull request, they'll say, looks good. Doesn't mean there's no bugs in it. Every commit should build on the build server. So this is the bit that really stops the works on my machine thing. Ensures the build is done repeatedly, reliably. Means that Bob didn't forget to check in a file. Means that Fiona didn't forget to get Bob's work when she built and tested the stuff locally. Just make sure everything works together and you can spot where the problem was introduced. And because it's a small change where the change was introduced, easy to find where you're talking about. Next one is fix the build immediately. So Kent Beck, who's one of the fathers in this space, back from the small talk days, he said, nobody has a higher priority than fixing the build. It's kind of like, hang on, but my job is to deliver this feature. No one has a higher priority than fixing the build. So the quicker you do it, the easier it is. And if you fix it straight away, the context is more likely to stick in your head. Makes it much easier. So if you're doing it 3 weeks later, it's going to be so much harder. And finally, keep the build fast. Well, maybe not quite finally, there's one more, but so you want to aim for really fast builds. 10 minutes is about the max you really want to do. A minute if you can get it. So it's all about the feedback loop. So if your build takes 2 hours, you're going to be off doing something else. You're going to be reading the news. You're going to be figuring out, laughing at what Trump's doing lately, and you've forgotten what you've been working on. So you want the fast feedback so you can stay focused, so you can remember what's in your head. And when you do it, you split it up into stages so that you'll get a high percentage of confirmation that it's successful early on. And then you get your more thorough end-to-end tests later. And finally, make it visible. So as we were talking about before, build radiator up on the wall. Imagine that as TV up on the wall where everyone in the team can see it. That's really just going to drive good behaviour amongst the team. So it's also going to give a good indicator of activity and really, really helps with the communication and sharing of what's going on, where we're up to, things going well, things going badly. You know that Bob hasn't just sat at home watching TV all day. You can actually see that he's doing something. Bob's a naughty boy, isn't he? So, moving on to continuous delivery. I know I'm going through this pretty fast, but I'm doing that so that we can dive into some more fun stuff and do some demos later, if the demo jobs are nice to me. So, continuous delivery is a software engineering approach in which teams produce software in short cycles, ensuring the software can be reliably released at any time. It aims at building, testing and releasing software faster and more frequently. So CI, all about building and testing, so continuous integration, building and testing, and continuous delivery, all about being ready to release. So Agile really brought the development teams and the business together and helped them deliver what they wanted faster, or build what they wanted faster. So continuous delivery is an extension of that really helps it include the delivering the release, get the release out. So it puts the feature release into the hands of the suits, or the business. So continuous delivery was kind of coined by this book by Jez Humble and Dave Harley. Once again, worth a read. This one's probably even drier than the other one. So read the second half before you read the first half. Apparently they wrote it in the wrong order. That's what they said, not me. So, CD principles. So, build quality into your process. So, Deming said, cease dependence on inspection to achieve quality. Eliminate the need for inspection on a mass basis by building quality into the product in the first place. So Deming was considered a father of the lean movement, lean manufacturing. And that, talk about that a bit later. But lean manufacturing is all about cutting out the waste to improve speed and quality. It's all about continuous improvement. So in the context of IT, inspection on a mass basis is, well, I've just finished 3 months coding, someone else test it. So that's mass inspection. So if we can build the testing into our development process, we're going to have a much better, be able to deliver fast, have a much leaner process, much more efficient process. So building quality in it's cheaper to fix issues immediately, that fast feedback loop. And so that fixing bugs found days, weeks, months later, it's like, why did I make that decision 3 months ago? I don't know what I did last week. I can't remember anything. So how am I going to know why I made a decision to do it this way rather than that way? So the faster you can find it, faster you can find the issue, faster you can fix it. And then you just go on to manual testing is really, really expensive and time consuming. Just imagine if you had a 400-page test script. It's like, who's going to be awake by page 312? Who's going to be awake by page 12? It's a waste of skills and money for testers to be doing manual testing. Because, brain not working. So it's let's get humans to do the high value tasks and get them to do the exploratory testing. Let's get the repetitive stuff done by computers. So small batch size. So we've already mentioned this a little bit. So traditional approach, and one that seems logical, is like, well, when we do a release, we have problems. Okay, so let's do it, and let's do more testing, more sign-offs. So after a while, you start going, I'm only doing one every 6 months, and it fails every single time. Because when it comes down to it, if you've got a release with 200 changes in it, so each one of those changes, the developer is 99% sure that there's no bugs. 99% sure. You kind of go, actually, that's pretty good. I'd take something with 99% chance that it's solid. When you've got 200 changes, 99% times 99% times 99%, pretty much you're at guaranteed failure. And so because you're on small size, smaller area of change to find it, and because you're on small batch size, you're releasing more often because you have to, so it's faster to fix it. Rather than, we can do a release every 6 months, but we're guaranteed to have bugs, and we're not going to fix it for another 6 months. Or we can do a small batch size, ship it today, oh, there's a bug, I'll ship it later today. And that's what we do. We ship bugs sometimes, but we fix them, and we ship them a couple of hours later. So small batch size gives you the reduced feedback time. It even just gives you the increased motivation. So if you think about it, it's like the change I worked on last year still hasn't hit production. Am I going to feel motivated, excited? Am I going to feel enthusiastic about what I'm working on? Not really. So if I'm actually making a change and seeing it get to customers, seeing it get out to our users, or even just seeing it's like, I made a change and our baseline revenue went up 10%. Deal. I'm going straight to the boss and ask for the pay rise, but yeah, you can actually get a lot of intrinsic motivation out of seeing success so strongly correlated with your actions. It also avoids wasted time on things that never go anywhere. You don't want to spend 6 months and then realise that that's actually not what the users wanted. So I was reading something the other day, out of 1 in 3 changes that we ship actually have the desired outcome. Even though really good, smart people, this is as a general rule, not specifically Octopus. So the best of intentions, we think this will have the right behaviour on the customers, or this is what the customers want. And it's a 1 in 3 chance that that'll actually happen. So if we're doing small batch size, we can actually ship the stuff quickly. We can find out sooner rather than later that things are what the customer wants or not what the customer wants. And we can be agile, really. So doing this really just means you have to make it easier and cheaper to deliver, which means automation. So, which brings you to computers perform repetitive tasks, people solve problems. Computers are great at that. So, and people are not so great at repetitive tasks. They get bored, they start thinking about what they're going to do on the weekend, they start thinking about the pub. They're going to get sidetracked. The computers, they don't get sidetracked so much. So Toyota, which is an odd thing to be talking about, but Toyota pioneered a lot of this stuff about continuous improvement. They had the idea of jidoka, and I'm not good at Japanese, so apologies if that's pronounced badly, which that means automation with a human touch. It really comes down to don't waste money on people doing things that a computer can do better and faster. Release your people to be working on higher value activities. Because really it's like humans are most error prone when you're doing mindless tasks. So a related one is Kaizen, another Japanese word that I'm probably mispronouncing. And that means continuous improvement. So it's all about relentlessly pursuing continuous improvement in everything you do. So avoid being satisfied with the status quo. And there's always opportunities to improve things. So if you're in a place where suggestions for improvements are being blocked left, right and centre, then you probably need to think about going somewhere else. But you need to aim to be in a place, you need to have a culture, work in a culture where improvement is the name of the game. It's not necessarily easy, there's always challenges, but it will give you a much better sense of quality of life. And so related to that is kind of everyone is responsible. So there's no such thing as passing the buck, no such thing as somebody else's problem. So it means your developers end up responsible for stability and operability, and operations ends up being responsible for helping the devs to achieve quality. So that really means you need to make everyone responsible for the organisational goals, not optimising for their team. One largest company I worked for, they had the development department and the operations department. The boss of the development department was rewarded, he got bonuses on how many changes they shipped. The operations department got bonuses based on how stable things were. So operations never wanted to change anything. So the two parts of the business were like at loggerheads based on the rewards that the managers were getting. So they're kind of like, your company ends up locked and unable to deliver anything. So optimise for organisational goals, not team goals. Right, so before we move on to DevOps, it's worth talking about the old school stuff. And quite like that picture, but the Ford Transit in there is not quite as old as the car, so. Right, so the old school, which is not necessarily that old because there's still a lot of companies doing it. They don't call it waterfall, but they're still doing waterfall. So, interestingly, the original description of waterfall had little feedback cycles in each stage. And it's like those feedback cycles that really made this whole thing work. But no one does the feedback cycles because they look boring. So it's all about throwing things over the wall. So you end up with your software deployed by people who don't know what it does or why. They just get handed a document that's written the day before by someone who doesn't want to, and they just whip together something and say, okay, there you go. And it's like, How many times have we actually tested that deployment process that we wrote quickly with not very much motivation yesterday? We've never tested it at all. That's guaranteed failure. So anytime we get these guaranteed failures, people add quality gates. We need another quality gate, another sign-off, more testing. So all of a sudden you've got more testing than you've actually got development. But these quality gates, they're sign-offs by people that are divorced from the change. They don't know what's actually the content of what's changed. Most of the time they don't even know why. So that happens on the sign-off testers. So you've got the people who can't see what's happening inside this black box. They can just see, okay, I'm told it's supposed to do this, but I can't see the bits that's actually really the edge cases. So you end up in a place where you've got pretty much low trust. No one really trusts anyone, and we just end up just not delivering anything. So you end up in a blame game. And so that's where DevOps really comes into things. So I am really thirsty. I will stop for a second. So CALMS. CALMS is one of the key aspects of DevOps. So, and it stands for culture, automation, lean, manufacturing, and measuring and sharing. And out of those, culture is the most important. And this is the bit where it's kind of like, you know what? Culture's hard. Culture is, it's like, I just want to code. It's like, no, but the way we communicate, the way we work together is actually the most important thing. That's how we're going to be more efficient and actually deliver the best thing. It's about relentlessly pursuing continuous improvement. If you're the only one in your team that's got a passion for improvement and everyone else is just there for the paycheck, you're going to struggle a bit. So you need to have a culture of continuous improvement, culture of trust, culture of communication, a culture of shared goals and shared vision, which pretty much means you need to have one team. You need to have a product team, not a project team. If you're a project team, your people are going to disappear as soon as the project's over. How are you going to support this in production if the people who know what's going on have disappeared? So you need to get everyone into one team, and that's the developers, the testers, the security, the operations, everyone in the same team, working together with the same goals. A is for automation, but interestingly, automation is not the goal. It's the fast feedback is the goal, but the automation is the enabler that's going to get you there. So you need to automate to make things faster, more reliable. So you're looking at things like one-click deployment. You need to be able to get your stuff out there quickly. You need to look at server automation. It's like you don't want to wait 12 weeks to get an environment provision for your testing. I want to click a button. Automate your dev laptops so that you don't have people starting up on their first day and they're spending 2 weeks configuring their laptop to get going. You want to automate your testing, your security scanning, your perf testing, which all comes down to operations need to learn to code and developers need to learn ops. So they're automating the right things. So it brings you on to lean. And we mentioned lean just before in Toyota. So lean principles come from Toyota and the Toyota production system. And there's actually a lot of really interesting things to learn about how Toyota really did this stuff. So lean is defined as a systemic method for the elimination of waste within a manufacturing process. So in the context of IT, waste is work that provides no value to a product or service. So if you think about it, it's like, what value does shipping a bug to production do? Not much, because that means, well, we're going to find the bug and then we're going to have to come back and fix it. Well, let's do it right the first time. It means waste can be waiting. So you don't want to wait for another team to deploy your software. That's just, why do you want to, what's the gain in your request sitting in another team's queue? You don't want to be firefighting. You don't want to be wasting your time with fixing issues from production. Let's build the quality in to the early stages of it, so that you can focus on delivering value rather than fixing stuff that's already out there. Measure. So, measuring is really important in the world of DevOps. It's like, instead of just going, I think we should do this, measurement gives you that way of knowing what to do and why, and whether it's successful. So once you start measuring things, get them up on graphs, get them up on the wall, get them up on your radiators up on the wall. Because once you've got those graphs there, the human brain is great at spotting anomalies. So imagine you've got your graphs up there of your sales across the day. So you've got your peaks and your troughs there. All of a sudden your number of sales drops to 0. You probably want to be on that pretty quickly. If your number of login attempts spikes, you're probably getting hacked. So you want to. The great thing about having these available is they're really great to jump out at you and really help you get great feedback and spotting opportunities for tweaks. So you really want to measure as much as possible. So data storage is effectively cheap. Let's measure it, and then we can figure out whether we actually need it later. Which means you really want to make it really easy to track metrics. So you want a one-liner change to your code base to add a metric to do something. Successful logins, failed logins. You track your flow through your website, where people are dropping off, where you're making purchases, so on and so forth. The last one in this is share. So sharing. And this is kind of the one that's actually probably a bit harder, because as IT people, we're generally on the more introspective side, but actually it's the second most important out of all these. And because sharing is the bit where we communicate well. We share success, we share failure, we learn from other people's mistakes. Let's not keep repeating other people's mistakes when we've seen great examples of how to do it better. So we want to share amongst the team, amongst the broader department, the company, the world. So it means you want shared code, shared tool sets. So you want shared stand-ups, so get all the people that are related to your product in the one room, in the one spot. So you're going to actually spot, it's like, oh, you don't want to do it that way because of this reason. You're going to get all the experience come together, as opposed to doing it in isolation. You want shared success and shared failure. So if something goes wrong, you want a shared post-mortem. So everyone can learn about what's gone wrong, how we can do it better next time. You want shared language, so harks back to DDD and the ubiquitous language there. So when you're talking about something, everyone knows what you're talking about. There's no confusion. You want shared ownership, so which comes back to the product team, not the project team, and everyone owns this. So it's not someone else's problem, it's our problem. So if something's going wrong in production, that's our problem. Comes to shared feedback. So you've got your dashboards and stuff, but even more so, you've got shared pain. So when you get your developers on call, you'd be surprised how quickly those 3 a.m. problems get fixed. So once you've got the shared pain, once everyone knows what pain is happening to the shared team, you're going to find those things that are affecting those ones in production. So I work for a company in the UK called Trainline.com, the UK's biggest train ticket retailer. And so the support guys, every day they had to go and clean up the log files, and they because they were the bottom of the waterfall, they weren't able to get any changes back into the pipeline, because the devs were all about features coming from the business up here. So so they couldn't get the one-line configuration change where the log files would clean themselves up. So they had to write a script to do it themselves, which is all good, except that they had a bug in it and it deleted all of the production servers. So because they couldn't they weren't able to share the pain because dev and support weren't sharing the pain. That was a 10-hour outage, and I'm pretty sure it cost about £1 million. So it's like one line configuration change would have solved that. So the other aspect of DevOps is what's called the 3 ways. And this actually comes back a little bit further, comes back from, it's been around a bit longer than DevOps, but it's a great way of looking at it. So the first way is systems thinking. It's talking about the flow should always go one way. And you should always, it's all about flow, and it's the flow from dev into ops. So you really got to make sure work only flows in one direction. So kind of sounds like, well, actually, let's prevent bugs hitting production. So no known bugs or no known defects should be passed downstream. So if you think of IT as a value stream or a manufacturing line, each work center is going to add value. You want to make sure each work center is going to do it right the first time, so that stuff doesn't have to come backwards and then go forwards, waste time. You want to do it once, you want to do it right. And yet the second way, which is about amplifying the feedback loops. So the goal is to shorten those loops and amplify them. So it's all about continual improvement. It's about really understanding what's happening with your software, how it's actually working in the real world, as opposed to in the magical world of the happy path. And it's like actually using that information to inform and make better decisions. So once you've got this information feeding back in, you're going to start embedding knowledge where you really need it. So when you find out that the way we've designed our software, it means that, well, actually, for every 10 users, we need another server. Okay, we probably need to look at our architecture to make a few improvements there. But otherwise, if we're only thinking from a dev point of view, say, oh, that's an ops problem, they can just throw more servers at it. So there's a sign on one of the Toyota production lines that reads, improving daily work is more important than doing daily work. And it's kind of a challenging thing. It's like, hang on, I'm being asked to deliver this feature, but I also need to improve this as I go. Never said it was going to be easy. Rewarding, but not easy. And then you come to the third way, which is a culture of continual improvement and experimentation. And learning, should I say. So, culture of experimentation, taking risks, taking good risks. So you've got to learn from when you make a bad risk, learn from failure, but make good, have little experiments. It's like A/B testing, for example. It's like, I think that if we change this thing, our revenue will go up. Okay, it went down. Okay, let's go back and do it a different way. So this is enabled by the small batch size and the automation that's going to get you out there. So if you're making experiments, did that work? And because we're measuring things, we can see whether they have worked or not. And then if they have, yep, we'll build on that. If they've not worked, okay, back to the drawing board. And this really embeds, really encourages your culture of continuing improvement. DevSecOps. So no mention of DevOps could really miss talking about this. So it really is just an extension of DevOps, really. The only reason it's got its own name is because people were ignoring it. But if you think about it, it's like in an organisation, the ratios usually end up about 100 devs, 10 operations staff, 1 security engineer. They're not going to be able to they're not going to be able to be everywhere, so they really need to be embedded, they really need to be injecting the knowledge around, really making sure everyone's lifting the game. So it's you're looking at things like security unit tests. So it's an education game, educating the developers and the ops guys how to do this stuff. So security unit tests, like static and dynamic analysis. So constant security scanning of your production infrastructure. It's really just the continuous testing, continuous. Because just because you were secure yesterday doesn't mean that they haven't just found a bug in sudo that lets you have complete access, for example. Another way is bug bounties. We're using that to great effect. So you're actually paying per security bug found. Works a treat, actually. And Docker and containers work really well because you can test these and because you know you're shipping this thing the whole way through. It is immutable between now and production. Works a treat. So, I don't know if you can actually read that, sorry. But the 2019 State of DevOps survey shows a really strong correlation between DevOps practices and what they call elite performers. So out of all the respondents, they categorised it down, so elite down to low performers. And they found that the elite performers, they were having 208 times more frequent code deployments and 106 times faster lead time from commit to production. So once you're getting this high performance stuff, you're getting massively faster throughput. But you're getting a lot more stuff going through. How are you going to do it? How's it looking when you look at stability? So 2,604 times faster time to recover from incidents. That's fast. And 7 times lower change fail rate. So changes are 1/7 as likely to fail. Even though we're doing 208 times more deployments, and we're doing them 106 times faster, where our failure rate has gone down massively. How can you argue against those numbers, really? So, a couple of really useful books in this. This one's The Goal by Eli Goldratt. It's actually all about manufacturing in the 80s, which is an odd thing to talk about, but it's all pretty much related. So this book is pretty much responsible for turning around the US automobile industry. They were in danger of not existing, and this is how they figured out how to make it work. And the Phoenix project is a similar one, but sort of updated and talking about IT and bringing the same kind of mindset, the same kind of model to IT. Both of them are novels. They're pretty easy to read. They're not dry like the earlier ones I mentioned. Worth a read. And this one, the DevOps Handbook, is a really good hands-on guide. Really, this is how you change an organisation and how you be effective in making your change work. Which brings us to demo time. And this is the bit where it's all either going to go horribly wrong or it's going to go really well and it's going to be amazing. What do you reckon? How are we going to do? Are we going to be amazing or are we going to... It's going to go horribly wrong. Show of hands. Amazing. Or horribly wrong. we'll talk later. Right. So give me a second while I get this.
I'd add one more book to the list, which is the Toyota Way for Lean Leadership, which talks more about the principles of how you get the team organised around the idea, rather than the mechanics, which is what they want to talk about.
Woo! I have internet and it is working. Even better. Nice. So this is Octopus Deploy. And as I mentioned earlier, Octopus Deploy is a friendly automation deployment automation tool, should I say. And so it is not a DevOps tool. And if anyone tries to sell you a DevOps tool, they're selling you snake oil, because DevOps is culture. It's about how you work together. It's not a tool. And I'm not looking at you at all as your DevOps. Right. Okay. That's it. Not going to rant about that anymore. So this is Octopus Deploy. As you can see, this is the dashboard you get when you first log in. you can see the projects we've got down here, and across the top you can see our environments. So dev is where we're going to, is that big enough? Can you see that? Yes? So dev is where our developers are going to work and constantly deploy. Test is where we're going to get some like customer sign-off maybe. And production is where we're going to get some real users. And so we can see our projects, we can see for each project we can see what's in, at a glance we can see what's in each environment. So when you look at this you kind of go dev, test, prod. Yeah. So one of the powerful things you can do with Octopus is that it lets you have life cycles. It lets you define how your code flows through the environments. So normal changes, we're going to go dev, test, production. Hotfix, yeah, we don't have time to get that out. Okay, super important fix that we need to get right out. Now just go straight to production, hope for the best. And so you've got your environments, you've defined how they flow through the environments, how your change flows through. And so then you've got your deployment targets within each environment. So you can either have your Kubernetes cluster, you can have your Windows VM, your Linux VM, Azure web apps or AWS stuff. And so for this particular one, we've got the same machine because we're cost cutting. Same one is dev, test, and production. It's the same machine we're going to use in all three of them. But we've said that this machine is a database server. It's where we're going to deploy our web app. So we're going to deploy our web server. We're going to communicate securely with that, using that connection there. So, okay, so we've set up our environments, we've set up our infrastructure we're going to deploy to. So on our project here, let's have a look at the Phoenix project because why not? So at a glance you can see where we are through an environment. You can see that currently in production we've got 5.11. We can see that 065 hit dev, but it's got some warnings for some reason, and then they fixed that in 066. But we haven't deployed that out yet. So you can see at a glance where we're at with our deployments. So you can imagine that's stuck up on a radiator up on the wall. You can see, the entire team can see where we're at with things. So we've got our project, we've got our environments, and so what are we actually going to do when we deploy it? So here's the process we're going to go through to deploy this stuff out. So we're going to upload a package to an S3 bucket. We're going to deploy a web application and then configure Nginx as our proxy. And then we're going to deploy our web service to our Windows web server. So a nice defined list, repeatable, reliable deployments. It's shared. Everyone can see this is how we deploy the prod. We don't just copy stuff around and follow a document. This is the executable version of that document. So once you've got that, you've got your variables that you can inject into each bit. So you can see for our database connection string, for dev we've got a different value to test and prod. So these we're going to be pointing to different databases depending on your environment. You can see for our AWS account we're going to be using the AWS Developer Playground for dev and test. Doesn't look like we've actually got one for production, but. And there's the certificate we're going to use for SSL. And if AWS region, we decide that we don't want to deploy this into Singapore anymore, let's change that to AP Southeast 2. We're deploying it to Sydney. And so just with a tweak that value, create a release, deploy, we're laughing. So looking at a different project, I've got our Octo Pet Shop. Got our different steps here. Deploy a website, update the database, run a script to update our database, deploy these things, and this one's got in production we're going to do a special step to tell the company team leaders that we're done, we've deployed it. This is all good because this is how we're going to deploy our software. But there's a lot more to deploying software than just and deploying and running software than just deploying it. Because once it's out there, well, sometimes you need to collect the logs. Sometimes you need to restart the web server because it's hung. So something that's pretty new, runbooks. So say for example we need to switch over to our disaster recovery site or take a memory dump or any of those actions there. We just kick this off and we're going to switch up ENS so we're over on our disaster recovery site. I'm pretty stoked about this. This makes life a lot easier. It is pretty new, so that's why I'm happy. And finally, just to wrap it up, this is a super quick overview. But when you're creating this, your steps, there's a massive library of community contributed steps to get you going. If you name it, you've probably got a good chance of finding it there. So that demo over. So I'm going to go boom. Ooh, and that's worked too. Bonus. So you've seen the product we write, we release. But how do we actually do this? How do we actually work? So we're actually a remote first company. So I work from home. The company's based in Brisbane. So we've got a pretty high need to communicate well. So we're always on Slack, always on video conference calls. And yeah, so there's a high need for communication because you don't get those water cooler conversations. You don't get those, let's go out to lunch and talk about that. So it changes the way you need to communicate. It's a high trust organisation. So high trust that the boss gave me his credit card and then said, anything less than 10 grand, don't tell me. So, okay. It's a bonus. He hasn't caught me yet. So high trust organisation. Very engineer heavy as far as these things go. We've been scaling up our non-engineer side, but at last check we're 56 people, half of which is engineering. The rest is sort of finance, sales, customer success, support, so on and so forth. So we're a very product-focused company. A lot of the time, if you're in an enterprise or a lot of organisations, you're working on that company's product, so you've only got one production. You've only got the one thing to deploy. So we've actually got thousands of customers. I actually don't know at the moment. But everyone is running different versions. So it brings extra complexity into things. And the good thing is we're by engineers for engineers. And that's quite good because when we get a support ticket, the people asking for help usually they have a good level of technical expertise. But it also does mean that you don't get many simple questions. And we try and do a lot of stuff in the open. So we try and write about what we're doing. We open source by default for our code. We like talking about and like sharing what we're doing. And that's good because that engages our customers, know what's coming, know why we're doing stuff and so on and so forth. But it also means that they're quite engaged in what we're doing. So there's an awful lot of good ideas. And that's really good, but it's also hard because there's too many ideas, not enough time in the day. So, but how does that actually plan out? How does that work? So we really try and do an iterative approach to work. So we try something. Is it working? Okay, what's working about it? What's not working about it? Okay, what can we adjust? It's that experimentation. It's that feedback cycle. So we've tried high trust, hire smart people. They will do good things. That produced some really good fruit. Also had some downsides. We tried functional teams. So we had teams that looked after execution, the modelling, usability, and that had different benefits. We had a lot of expertise gained in that, but also it meant some things got dropped. So now we've evolved to something called the shape-up approach by Basecamp. And so we end up working in a sort of an 8-week cycle. 6 weeks of focused work, and then 2 weeks of undirected cool-down time. So in that 6 weeks, we've got fixed time, variable scope. And in the 2 weeks, you look at, you pitch things to work on next. Because we've got lots of ideas, not enough time. So we've really got to focus on what is going to deliver the value for the most amount of people. So we've got our focus teams working hard as a way, but we can't have everyone focused and non-interruptible. So we've also got the quick response force. And they're a bit like the quick response force in the army, deployed to where they're most needed and most effective, but not meant to hold land. So we're not meant to create new features. We're not meant to deliver new functionality. So everything we're doing in the quick response force is 1 day max. So, and you start each day anew. It's like, where can I be most effective today? So that's all well and good. And that's all quite theoretical, but how does it actually work? So this is the bit where it gets even more fun, because I'm going to actually go and ship a prod change right now. And what can go wrong there? I mean, really. So while I'm talking, I will set up a laptop, because unfortunately, the code I'm going to work on is only working on Windows. So I need to swap from my Mac to my Dell. So, hypothetical situation. We've just opened a French office, and the French team are pretty good. They're pretty ace, but they've got this fixation. They quite like their language. They quite like French. And frankly, I don't blame them, because I like French too. And they've kind of gone, you know what? All the software is quite Anglo-centric. And so what I really want to do is, I even have internet. Bonus. What we want to do is make our software a bit more approachable for our French colleagues, keep them happy. So one of our key bits of software is ReleaseBot. So if we dive over and have a look at our shipping channel, there's a lot of words there. But if we have a look, so you can see at 5:19, Ben Pierce decided to ship 2019.10.1. And ReleaseBot came along, said, here's what we're going to ship. It goes through the process and ships it out, and then there we can see it's all released. So the great thing about this is everyone knows what's happening. Everyone knows how to do a release. So we can see, and it's quite descriptive what it's doing, and there's links to everything to say, oh, okay, yeah, so we're closing this milestone in that repo, we're doing this, we're doing that. So, even then we've got an audit trail of what happened. So someone can look back and say, okay, what happened here? Why? What's going on? But if we go, so that's ReleaseBot. So if we go, hello, we talk to ReleaseBot, and ReleaseBot says, what's up? And if we go, bonjour, in our best French accent, it says, I'm sorry, I don't understand. So our French colleagues have gone, I need a bit of language equality here. So this is a little bit of a made-up scenario, but it's one that we can actually show you a real change. So what I'm going to do, and I could have sworn I was supposed to prepare what I was going to do there. So probably can't see that terribly well, but frankly, the actual details of the changes are not that important. But if I switch into presentation mode, even better. So details aren't that important, but up here we can kind of see that it listens for words like hello, hi, hey there, howdy, hey. So if we, in theory, if we go add bonjour here and salut, which is French for hi, so in theory now it should respond when you say bonjour to it. We also wanted to reply in a bit of French, so let's change this one, bonjour, and I was going to go and research and try and remember how to do something a bit fancy than just good morning or hi, but I didn't. So, okay, this is all good. So, yeah, we can ship it, yeah? Can we ship it? Should we ship it? This is the interactive part. Can we ship it? Should we ship it?
What could go wrong? Yeah.
But we didn't write any tests though, did we? So what we want to do, we need to go hello message handler fixer. So let's actually test that what we did actually works. So we're going to say, if we say bonjour to it, it's going to respond correctly. And if we say salut to it, it's going to respond correctly. And then we also want to go, okay, we also changed what it could say back to us. So we want to get it to remember those two as well. So if we go bonjour there, really should have picked two different things there, shouldn't I? Bonjour and salut in both spots is a bit boring. So, okay, so now, in theory, we're testing that when we pass this greeting in, it's going to come back and say, yep, I've returned one of those things there. So if we run these tests, thank you, Windows Defender. Oh, yep, we've got green tests, so we're good to go. So let's exit that one. Okay, so now we've got different things on the screen. No, it just changed. There we go. So we're using Git, we use GitHub for this stuff. So using GitHub desktop here. And so we're going to create ourselves a branch, speak French. I should have said parler français, shouldn't I? So what we're going to do, we're going to create a branch. We're going to say teach release bots So what we're going to do here, we're going to say, okay, that's what we've done. But one of the important things here is why we've done it. Because future me is going to go, hang on, why did I teach release bot to speak French? What was the point of that? So the why is as important, if not more important, than the what. So we're going to say to keep French colleagues happy. And because this is actually one of our production applications, this is a real life application we use on a daily basis. I'm actually not going to say that because that's going to confuse people more than anything. As part of a demo. So, okay, we'll commit that into my local copy of the source control, and then we're going to publish that out to GitHub and create a pull request. Now, I have hopefully teed up one of my colleagues from Scotland, a lovely chap by the name of Derek, if you can understand his accent, but don't tell him I said that. So I'm going to actually assign this to Derek and create my pull request. So we've created a pull request, and a pull request, if you don't know, is a request to pull some code into the main code base. So I will get Derek on the case. And what's he going to say? I am ready when you are. Awesome. We're going to say, can you review this for me, please? Right, and I hope I actually hit paste in there. I did. And so he's going to hopefully be ready and waiting for me. He blocked out the diary, so I was fingers crossed he's going to be there. And so he's going to look at the code I've written. He's going to say, does this fit with the ethos of the application? Is this a good thing? Do we want to take on the maintenance burden of this change? Does it have tests? Is there a Muppet mistake in there? So it's a way of getting a peer review, and it's a peer review by someone who knows the code. So they can make an informed decision about what's going on. So while this is actually sort of kicking along, we can actually see, in theory, that all checks are passed. So all checks, what's that mean? So continuous integration has, so our CI build has kicked off. And if we dive over to that, and we can see here is the build. So we created our branch, our pull request. That's kicked off. That's run our tests. We've said, yep, here's our new tests here. So we can see that it's gone up from our last master build. We've got 2 more tests, and that's passed successfully. I'm just going to check if Derek is actually there. And, well, he's online at least, so we'll see what happens. So in our build here, we can see that we've pulled down the required dependency packages. Can you see that? Is that too small? Let's make it a bit bigger. So we've run SonarQube. SonarQube is a static analysis tool. So we've run our security tests against the code base, make sure there's no issues. So we've built the code using Visual Studio. We've run the unit tests, and then we've pushed our package out to Octopus to do the deployment. And then we push some metadata about it, so we know where the change came from, and we can link it back to the Git commit. So that's just a branch build. So that hasn't kicked into where are we? Speak French. So that hasn't kicked off our deploy to production, because we don't want our branch build to go to production, do we? So, and Derek seems to have gone AWOL. He's probably gone to get a coffee. So we're going to just pretend that Derek's come along and reviewed it, and he's gone, yep, it looks good. So you see, he would have just gone through, looked at the code. So that, yep, that looks like the changes I made. I may as well review it and make sure I haven't actually done any Muppet mistakes. Yeah, that looks pretty convincing to me. So we'll just pretend that Derek's actually come along and reviewed it. And I'm actually doing something a little bit bad here. So I'm skipping one of our safety nets. And before I did talk about quality gates are bad. The quality gates that are done by third parties, by people who are not close to it, they're bad. When you've got someone who knows the code, someone who's close to the code, someone's close to the change, okay, looks like he's just merged it for me. Okay? Oh, he's merged it for me. Bonus! I will take that as a, oh, and now he says it looks good to me. Cool, bonus. So So we've had the benefit of someone that's close to the code looking at it and checking that it's doing what we want. So that's not where we want to be. We want to be over here. So now we've merged our branch. We want to go and have a look at our default branch here. And we've got a couple of them kicking off. Don't think we need two of them. And I don't want to wait 11 minutes. So I'm going to jump to the head of the queue. And of course, when you're trying to do a demo, all of a sudden someone else wants to do some work, don't they? So hopefully that won't take too long to go. So we have that ready in queuing. And so that's going to go through, run our tests, our build, and then it's going to kick off and deploy into production. I knew something was going to go wrong with this demo. But hopefully not, we won't need to wait too long. So our 10 City server actually runs on dynamically provisioned infrastructure. So at the moment you can see we've got 11 agents sitting there. During the day that spikes up. We can have up to 70 VMs that are launched on demand, and these are all scripted. And then when there's nothing in the build queue, it scales back down. So we only have the VMs around when we need them, and the bonus is that it's cheaper as well. I can't say 70 VMs are that cheap to run when it comes down to it, but it could be much worse. So, oh, come on. Maybe I'll do a dance. No, let's not do a dance. So I've got 1 minute left. So when that kicks off, that's going to go over to our production deployment server. And if we have a look at, search for a release bot here. So we've got a bit of a YOLO life cycle here, so we're going to deploy straight into production when we're done. And so let's have a bit of a look and see what we're doing here. So when a change gets a release gets created here, we're going to send a Slack notification. So we're going to communicate. We're going to say what's changing. We're going to share. We're going to say what's changing, who's changing it, and include the why. So so the team knows what's going on. And we're sharing, we're communicating. And where are we? Come on. How much do I have to keep talking? Less than 1 minute to kick off now. Just kick off.
Matt, how do you deal with changes to open source components that are built into your tool chain?
In what case? What do you mean? When they break things?
Yeah.
We usually try and catch that with review. So it's one of the challenges of open source stuff is when you get a PR come in, you don't necessarily want to build it on your infrastructure because they may have injected a malware into it. So there we go, we kick off. So we try and encourage people to review our contributing rules. So please talk to us before you go and do any work, because if we don't agree that what you're doing is in the best interest of the project, you're going to waste your time, because it's kind of benevolent dictator kind of approach. So it's our project. It does. We've written it because it's something we need, but we're happy to help. We're happy to take contributions to make it better, but it needs to fit with our goals and what we need it to do. Yes. So that was the build that succeeded, and then we got our deploy to production, and so we've got 404 there, and we're just waiting for 40. And there we go. So we're kicking off, we're pushing that out, and we're waiting for the deployment to complete. So over here, that's kicking off. So we've notified Slack. So if we go over here, you can see that there's a change coming here. We're teaching release bot to speak French. And now we're deploying to Azure Web App, blah. So did that cover your question about open source?
Well, what about when you're using other people's open source stuff?
There's no such thing as a free lunch.
True.
So you get a lot of benefit by using their stuff,
Yes.
but it's their stuff and they can change it and break it.
Yes.
So it gets annoying because you go, how dare they change it? But then we go and do the same to other people. So, and it's like, okay, if you're using something like React, it's like you're building on millions of hours of other people's work. You kind of get a lot of benefit. So having to do a little bit of work now and then to deal with breaking changes, it's annoying, but it's kind of acceptable. So this is all deployed out, and as I said, we can go and sit in the Azure portal if we wanted to, and it's kicked off there. If we go and have a look at Slack, and we can see that it's come up, and now we've got version 404 in production. So in theory, I should be able to speak French to it now. And I've crashed it. Have I crashed it? Bonjour. What have I done? Right, okay. And this is the bit where our foresight has paid off, because we've got logging. And I should just pretend that this was deliberate, shouldn't I? This is deliberate, yep. Just show you how. Ignoring message because it was not directed at the bot. That's because I'm doing it wrong. I'm holding it wrong. How about we go release bot, salut. Yay! Phew! So let's do it a few times. So we can understand French, and it can speak French now, but for certain values of it. And so, back over here, and bish bash bosh, and if I'm right. So this is, bit of a demo, bit of a hypothetical situation, but really, this is actually probably a good example of DevOps in the real. So we had our unit tests, yeah, we saw them, we added those for our change, we saw them running, we got our peer review at the last second, so someone actually looked at it and made sure it made sense. We had our automated build, we had our automated deployment pipeline, we pushed it out. We had our fast build once we got past the build queue. So it was less than a minute to build, and even less than that to publish. We had our security testing involved. We had our fast deployment, we had our logging, we had our communication. So it kind of works pretty well as a kind of a nice end-to-end example of how this stuff all comes together. Because compare this to a change that I would have had to go to the CAB, the change approval board, and spend weeks trying to get this change out. And how long did it take? 5 minutes, if that. So I could see the effect of my change really quickly. I could see it wasn't something that's just like, okay, what's my next task? And now I've forgotten about what I've just done. I've got the sense of achievement, of kicking goals. And actually, yeah, so when you can achieve stuff that fast, your motivation is much higher. Right. And that brings me to questions. So thank you for the opportunity to come along and share. Hope it's been useful. And I'm not seeing anyone asleep, so I'm counting that as a win. So feel free to ask questions now. Feel free to come down and chat to me afterwards. Thank you. You don't have to.
Okay. There.
Oh, not you.
Robert,
So you said you changed the dev cycle to be 6 weeks, 2 weeks.
Our feature cycle.
Right.
Because the shape up approach came out of us, a problem we identified where we didn't have a lot of visibility about what was going on and when it would be delivered. So we scaled it back so everything has to be in a 6-week block. And so if it's more than 6 weeks, you can split it up in multiple things, but we're going to do 6 weeks, we're going to ship it, we're going to see. And then if you don't finish in the 6 weeks, the default position is we don't keep going. So if at the end of the 6 weeks we go, okay, has this achieved the goals we wanted to? Is this working out the way we thought it was going to? Are our customers happy with it? Is it actually meeting the customer's goals? And so it's once we know those answers, once our metrics, once our measuring tells us that, we can decide whether we're going to put more work into it or give up. Does that answer your question?
And that's what 2 weeks is for, is waiting for the feedback cycle?
Somewhat, but it also gives you a bit of a chance to do the improvement work, the process improvement, making things faster, better, making that horribly slow 1 minute deployment time faster. Well, not that that's bad, but it's also a case of so it's process improvement, it's cool down, it's recharge the batteries, sharpen the saw.
So is everybody on their own cycle, or is it like company in 6 to...
So we're actually all on the same cycle, actually. I think. Don't know. Haven't been paying that much attention.
We'll continue that over dinner. Sorry, everybody else.
so you guys are facing the end of your courses, is that correct? It's all about to graduate. How many of you have got jobs now? Okay. You are?
We are. As long as you're an experienced senior software developer with quite a lot of experience.
When you say senior, do you mean like old?
Not that old.
Would you like to talk about how it works with bug bounties?
Bug bounties, yeah.
Because do you have a bug bounty for Octopus?
Yep.
Cool.
So, pretty much bug bounty. We've got a setup particular Octopus instance that we say this is what you're allowed to attack. So we actually go out and we get reputable security researchers. There's a lot of non-reputable ones out there. And we just say, if you can find a bug within this scope, we will pay you money for it. So it's similar to what Google does, Apple does, Microsoft does. And so if it's like an XSS vulnerability, we'll pay this much. If it's a complete account takeover, we'll pay this much, and so on. Different scales of severity. And yeah, so it's just a case of connecting up clever, talented security researchers. They effectively do your security testing for free, and they only get paid when they find something. But given the general state of security out there, it's actually a tidy way to make money. So for example, we've been going for about 4 or 5 months on that. I think we've paid out about $500. So pretty stoked about that. For example, Seek, the job site, they've paid out 170 grand. But they've been running for about 4 years, and they've got many sites. And they keep on acquiring new sites, so their scope is a lot larger than ours. So if you want a bit of spare money, it's well worth doing. I think they all want to go to the pub.
Maybe they're shy. Well, I'd like to thank you for coming along.
That's good, my pleasure.
This instead.
Oh, thank you.
Grab it the left, shake it the right.
Cool, thank you.
No worries. Thanks for coming in.
My pleasure.
Okay.
And yeah, feel free to come and have a chat. Either to me or to that bloke. He runs a company, he's got 20-something years experience. He might be hiring. Are you hiring?
Yeah.
He's hiring.
Front end review, back end, .NET Core, SQL.
There you go. Now you got me worried.
Who was sitting here? There was Mikey.
Yours now.
Works for me. Works on my machine. Ah, conspiracy. Ah, I'm going to have a word with this man. Swinburne, sponsored by Microsoft DevOps.
She was my cousin. We are. We actually are, which is sadly.
Oh, okay, well, let's see what your dad wants to do. I'm assuming he wants to go back to his number.
Azure DevOps, it's good. It's got its place. Its place is on the simple end of things.
It's going to take a little
I
while.
promised myself I wasn't going to rant too much about that.
It wasn't that. It was the machine messed up. Oh, yeah. Just like quite. No, they're not. Anyway, let's see which one's the closest. We didn't wish to interrupt, but what was your plan?
Going back to my house. Oh, you know, I need dinner or something.
I'm not employed now, you can borrow me.
Oh, okay.
I don't like that again. Her is your house, because we went to your house.
A cup of tea and eggs and cake and.
Oh, good.
Because that chiropractor was
No.
for like 3:30, 3:45.
Or, as it turned out, 3:45 and 4 o'clock. Because somebody came racing it at the same time as me.
Well, let's all go and cover it somewhere.
Okay. I need to talk to your, yes,
Talk to my, he's the best one.
make tea. Well, I found it very interesting and I'm not even a DevOps.